talk about parametric relations, and relations defined parametrically. Now, another natural way to define functions, or more generally relations, is to define both elements of the ordered pair in terms of another variable t called a parameter. We illustrate with an example. Now, complete the following. Find the points determined by t equals -3, -2, -1, 0, 1, 2, and 3. Find a direct algebraic relationship between x and y, and determine whether the parametric equations determine y as a function of x. Then graph the relationship in the xy plane. So what we're going to do here, to find x, we're going to put it into x equals t plus 1. Well, -3 plus 1 is -2. -2 plus 1 is -1. -1 plus 1 is 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 1 is 4. Should be nice and simple. Now for y, it's going to be t squared plus 2t. So what we'll do, -3 squared is 9, plus 2 times -3, which is -6. So 9 plus -6 is 3. 4 plus -4 is 0. Then we'll put -1 in, so we'll have 1 minus 2 is -1. And then when you put 0 in, we'll end up with 0. Put 1 in, we'll end up with 3. When you put 2 in, we'll have 4. Sorry, when you put 2 in, we'll have 4 plus 4, which is 8. Then when we put 3 in, we'll have 9 plus 6, which is 15. So the ordered pairs that we come up with, we'll have -2, 3. We'll have -1, 0. We'll have 0, -1. We'll have 1, 0. We'll have 2, 3. We'll have 3, 8. And then we'll have 4, 15. Now when we plot these points, we'll plot -2, 3. -1, 0. 0, -1. 1, 0. 2, 3. 3, 8. And then we'll have 4, 15, which would be pretty high up. Put a line through them. That's what we have. There's the point 4, 15. Now, to find it algebraically, what we want to do, we want to take this first equation, solve it for t. So t will equal x minus 1. Now we're going to put that into y. Simplifying that, x minus 1 squared will be x squared minus 2x plus 1 plus 2x minus 2, which means y will equal, well, the 2x will go away, x squared minus 1. So there's our algebraic relationship, and if you look at it, it does look like a parabola that is x squared that is shifted down 1. Moving on to b. When you put -3 in here, we'll get -6, then -4, -2, 0, 2, 4, 6. And then 3t minus 1, we'll have -10. We'll have -7, -4, -1, 2, 5, and 8. So here's our ordered pairs, -6, -10, -4, -7, -2, -4, 0, -1, 2, 2, 4, 5, and 6, 8. Now when we plot these, -6, -10 will be right here. -4, -7 will be right there. -2, -4, 0, -1, 2, 2, 4, 5, and 6, 8. So there's our line. Now when we connect them, that's what we'll have. Now, to figure this out algebraically, again, what I want to do, I want to solve the top equation for t. So here, t will equal x over 2. Putting this in, and simplifying, here's your equation. So 3 halves x minus 1, and if you look at it, it looks exactly like it is. So it's going to go up 3 to the right 2 for a slope, and a y-intercept of negative 1. It's the line y equals 3x minus 2. Now, when we're using example 2, again, using a graphing calculator and parametric mode, complete the following. Find the points, direct algebraic relationship, and determine whether the parametric equation determined y is a function of x. Graph the relationship to xy plane. Pretty much the same exact thing we just did. So when t is negative 3, we'll have, what we'll have here is 9 minus 6 is negative 3. When t is negative 2, we'll end up with 0. When t is negative 1, we'll have negative 1. When t is 0, we'll have 0. When t is 1, we'll end up with 3. When t is 2, we'll end up with 4. And when t is 3, we'll end up with, actually, correction, t won't be 4 when t is 2, x will be 8. And when t is 3, we'll have 15. Now for here, negative 3 plus 1 is negative 2. Negative 1, 0, 1, 2, 3, and 4. That means my points will be negative 3, negative 2, 0, negative 1, negative 1, 0, 0, 1, 3, 2, 8, 3, and 15, 4. Now to graph this again, really pretty simple. Negative 3, negative 2, 0, negative 1, we'll have negative 1, 0, 0, 1, 3, 2, 8, 3, and then 15, 4. I made a mistake here. Let's change this negative 3 into a positive 3. That should change things. Now when we make our graph, it will look just like that. So what do you notice about this one, example 2, and also example 1? You should notice it's exactly the same shape, just tipped on its side. So really, when we switch the x and the y equation, that's what we'll get. Now what we need to do, let's solve the second equation for t. So t will equal y minus 1. So we put it in here. X will equal y minus 1 squared plus 2 times y minus 1. Simplifying, x will equal y squared minus 2y plus 1 plus 2y minus 2. 2 y's will cancel out, so x will equal y squared minus 1. And that'll be your equation. And if you truly wanted to solve this for y, we'd end up getting y will equal plus or minus the square root of x plus 1, which is exactly what that is had we solved it for y. So you can see that it's going to be a square root function pushed to the left 1, which is what we got. Moving on to B. To find x equals t squared. Well, negative 3 squared is 9. Well, 4, 1, 0, 1, 4, 9. We'll have negative 5, negative 4, negative 3, negative 2, negative 1, 0, and 1, which means our points will be 9, negative 5, 4, negative 4, 1, negative 3, 0, negative 2, 1, negative 1, 4, 0, and 9, 1. Put these into your calculator. We'll have 9, negative 5. We'll have 4, negative 4. 1, negative 3. 0, negative 2. 1, negative 1. 4, 0, and 9, 1. Now, the funny thing about parametric equations, they only graph in your calculator when you want them to graph. That's all they graph in your calculator. Now, solving this equation and switching it to rectangular mode. So y plus 2 will equal t. Plugging this in. So y plus 2 squared, which means x will equal y squared plus 4y plus 4. That is your equation. Nice and easy enough. Now at this time, I'd like you to, well, after I'm done talking, I'd like you to turn off or pause the video and work on exploration 1. Now, in order to put your calculator into parametric mode, I'll show you that real quickly. To put it in parametric mode, you press the mode button, go down to where it says function, PAR, POL, and SEQ, go right to parametric and press enter. Now, when you do that, and you press y equals, you'll see they have an x1t and a y1t. That'll be your first equation. Your window should say negative 4 to 2 with a 0.1 t-step. For your x min, x max, we'll go negative 5 to 5. And negative 3 to 3. So that should be your window. Make sure you do that when you work on exploration 1. Now, if you should have any questions on exploration 1, we'll go over it in class, but it is good to play with the parametric mode to understand what goes on.